Okay, and here we go. Well, good morning, good afternoon, and evening, and probably night for some of you out there. Thank you all so much for being here today. And welcome to Developing a Vision for Improving the Discovery and Access of Bathymetric Data. This is a webinar series put on by the GEBCO Technical Subcommittee on Ocean Mapping and the IHO Data Center for Digital Bathymetry. My name is Jennifer Jenks, and I, along with Vicki Ferreira, will be serving as the series organizers and host today. As members of TSCOM and myself as director of the IHO DCDB, and Vicki as head of the Seabed 2030 Atlantic and Indian Ocean Regional Center, we are excited that you all have chosen to be here today to join us as a community, to listen, to discuss what's working, what's not, when it comes to the different aspects of the bathymetric life cycle. Next slide. Sorry, Hayley, I forgot to ask you next slide. We'll go ahead and go to the next slide, please. Thank you. So just a bit of background on the organizations behind this event. The TSCOM provides technical advice to maintain and improve GEBCO products and the supporting data, while the DCDB is the recognized IHO repository for all ocean bathymetric data with the intention to provide preservation and discovery and access to those data. Both of these organizations look to you, the community, for guidance and suggested direction on how best to drive the work that we do. Next slide. Both entities also strive to support the Seabed 2030 project. This is a collaborative project between the Nippon Foundation of Japan and GEBCO. CEBA 2030 aims to bring together all available bathymetric data so that we can produce the first definitive, freely available map of the global ocean floor by 2030. Next slide. CEBA 2030 is meant to act as an accelerator to fast track GEBCO's aim. And as you can see, they are. In 2016, only 6% of the ocean floor had been mapped to modern standards by data shared with the global community. And last year, that number had increased to 23%. But obviously what remains is, well, a lot. Next slide. Give me 1 second. It looks like I need to plug in my computer. That's what happens when we're live. Okay. And we know there simply aren't enough survey ships out there with the spare capacity to map 3/4 of the ocean floor in the time scale that we're looking at. We know we need to work to expand our community of mappers. In addition to using what we have, we need to really embrace new technologies and new sensors and new platforms. Next. But we also really need to focus our efforts on harvesting the data that has already been collected, but not yet shared with GEBCO. We believe that perhaps another 20 to 25% of the ocean floor has already been mapped, but the data has not yet been released. Next slide. 20 to 25%. That is a significant amount of potential data. Data that, if it would be contributed, would allow the community to focus resources on collecting new data in unmapped regions. But why? Why did these data remain unshared? So this is a quick list that jumps to mind, at least to the mind of the organizers of this series. But perhaps we should be checking our assumptions. Perhaps there are other reasons we haven't considered. And so to close this data gap, we need to first truly understand why it exists. And then all of us as a community work together to eliminate it. And with that, I'll pass the microphone to Vicki. Thank you.
Thanks, Jen. Next slide, please. So as we have been evolving as a global mapping community, we have been continuing on this collaboration continuum that's shown here. We've moved from networking to coordinating. We're starting to see more cooperation and collaboration, and hopefully we will actually get to the point of integration where we really work together as a community driven by common goals, trying to achieve efficiencies and lift each other up to help achieve these. Next slide, please. Why a TSCOM webinar series? Well, our objectives are threefold. First, we're hoping to identify and understand current activities and plans. We're also really hoping to draw some attention to community challenges and needs and think about how we might be able to address those challenges. What are the opportunities to address those challenges? Another important outcome of this webinar series is to inform a workshop that will be held on the Lamont Doherty Earth Observatory campus, which is where I sit in New York. That event will take place in late May, and it will be hybrid so that people who are unable to attend in person will still be able to participate. And as an outcome of this entire engagement, our hope and our intent is to develop actionable plans to achieve our common goals. This includes guidelines, workflows, and the sharing of tools. We're really here today and all this week to learn and to understand what's needed so that we can start to develop a plan for the future. Next slide, please. Some of the tangible outcomes that we intend to create from this engagement include white papers that capture some of the work that's being done, describes the current state and where we envision going in the future. We're hoping for example, a white paper on ocean best practices to help move the community forward. We're really hoping, as I said, to identify the barriers that the community is facing, and we recognize that those are a combination of both cultural and technical barriers that inhibit or slow down data sharing. And we're really hoping to capture and identify solutions, both in the short term and the long term, that we can aspire to achieve. This will help us develop a roadmap that really further defines the ways to move forward together, and also in particular, ways to help us better integrate information that exists about data coverage so that we can use the assets that we have to collect more data in the most intelligent and efficient way. Above all, what underlies all of this is that we are trying to help make community progress toward coordination. We want to avoid redundant effort, optimize efficiency, and foster a culture of open sharing of data, information, and knowledge. Next slide, please. What to expect in this webinar series? Well, today we're here for the fourth in a series of complementary sessions. These are panel discussions focused on different topics related to bathymetric data management, sharing, assembly, and access. Again, we're really interested in getting perspectives from the community about current barriers and opportunities, as well as future vision. And this virtual conversation is meant to inspire and gather input from the community. We don't want it just to be the people who are talking to each other in this live broadcast, but we really want to get more and more input from the community all around the world. Next slide, please. As far as logistics, we are broadcasting these live to YouTube with the intent of ensuring that they're available long-term. We hope that you'll share these links with your colleagues so that more people can engage in this conversation. During the live session, we are live polling the audience through a tool that is embedded in our slides. And after the sessions, we will be communicating with the community, both folks who signed up for being part of this series and also through listservs to gather more information and feedback. Again, a primary motivation for this is really to make sure that we hear the voices of members of our community and really understand the current state and what the needs and opportunities are. We'll be assembling all of the information that we gather into a post-workshop summary that we will share publicly online. Next slide, please. Just very briefly, a summary of the different sessions. On Monday, we had a session about data stewardship, focused on data sharing, obstacles to data sharing, and solutions that can help address bottlenecks. Next slide, please. Later that day, we talked about data discovery and how to identify data gaps. And in particular, the use and integration of web services, both for data discovery and for making data-driven decisions about how to opportunistically fill data gaps. Next slide. Yesterday, we heard some great conversation about data access, how people are accessing data, and what the community needs. What can we do as data providers to ensure that the needs of the community are met and that people are able to use this data in productive ways? Next slide. And today, the fourth in our series is focused on data processing, data transformation, and integration. A little bit more technical, talking about different ways that we interact with the data to assemble it into products that serve the needs of the community. Next slide, please. And just before I hand it over to Hayley, I wanted to express my gratitude and the gratitude of all of us who've been working behind the scenes to put this session together. The session leads have been amazing to work with and dedicated and very generous with their time as we've envisioned this series. The panelists who we've heard from already and who are joining us today, we deeply appreciate your contributions and look forward to hearing the conversation. And the community, we're here to really hear from you, and we appreciate the time that you've taken to listen and contribute your input and feedback. And with that, I will hand it over to Hayley. Thank you.
Awesome, Vicki, thank you. Give me 2 seconds to switch over my slides. Okay, make sure
Can everyone see my screen okay?
Yes.
Perfect. Thank you. Okay. Hello, everyone, and thank you so much for joining us today. The past 3 days have generated such fantastic discussions, and I'm thrilled to lead our final session on data processing, transformation, and integration. I am Hayley Drennon. I am a senior research assistant at Lamont Doherty Earth Observatory, as well as a part of the Nippon Foundation GEBCO Seabed 2030 project's IORC, or Atlantic and Indian Ocean Regional Center team. And while the conversation will mainly focus on our panelists, I will also be providing my perspective from the lens of a seafloor data manager for Seabed 2030. Oops, that's not supposed to be there. So we're missing a slide here, but let's see, I think, there we go, that'll work. It's just in the wrong order. As I said previously, or as Vicky said previously, this final session will focus on data processing, transformation, and integration. We will begin with how we're currently handling our data, the challenges we face throughout the data pipeline, and what vision we have for the future. And as you may have heard from session leads this week, our ultimate goal of this series is to gather feedback from the community and panelists and distill that information to generate tangible outcomes from our in-person meeting in May. Throughout the session, I will be posing a series of questions to you, our audience, in addition to the panelists. The polling platform we're employing is simple to use. It's AHA Slides. And I encourage you to either scan the QR code or type in the URL that you're seeing to the left of your screen in order to join us and answer in those questions. If you feel as though our multiple choice options are not reflective of your answer, or you need additional room to expand on your answer, feel free to add a comment by clicking on the Ask a Question bar at the bottom of the screen in AHA Slides. This will bring up a dialog box where you can submit your comments, questions, etc. And we may not be able to answer every single question from you today, but everything will be preserved and addressed for our May workshop. So today we will hear from our panelists, Dr. David Sandwell, Joshua Sixsmith, Christian Ferreira, and John Morton. But before we get started with the introductions of our wonderful panelists, let me pose the first question to our audience so that we can familiarize ourselves with how the polling will be conducted. So let's go back since it was out of order. What do you consider your primary role to be? So while we all take a moment to log into AHA Slides and answer this, I'll answer for myself. Because of the nature of the group I am a part of at Lamont, I wear many hats related to data stewardship, but the one I tend to wear most often is of a data manager. Specifically for the Seabed 2030 project, I deal with a lot of data from across the globe of a variety of different formats, data quality, and spatial footprints. Because of the diversity of these data sets, our team has developed different pipelines and approaches to ingest each of these in order to generate our regional Atlantic and Indian Ocean product. Thankfully, because of previous work conducted by my group at Lamont, data processing infrastructure and pipelines are already well established here for swath data in the form of GMRT, or Global Multi-Resolution Topography, as a tool for quality assessment. For raster review and integration, we tend to turn towards the BIS, or Bathymetry Information System, which can be found in Esri's ARC spaces. Okay, it looks like we're still getting some answers, but it looks like we've gotten quite a bit already. So let's hear from our panelists about who they are and their role and their work. We're going to start with Dr. David Sandwell. The mic is yours.
Okay, thanks, Hayley, and thanks, Jennifer and Tim and all the organizers for putting this together. I think I'm going to learn a lot, even as a panelist. So let me get started. Let me introduce myself. I got to share the slides. Yeah. Okay, so I'm Dave Sandwell. I'm a professor at Scripps Oceanography, and I've been working with Walter Smith here on the upper left to make predicted seafloor depth doing this for maybe 15 years. So I'm one of the older people here in the room. We fill those 75% of the gaps that we hope to fill eventually with ship data. And who you see here a number of other people that we've worked with over the years. Most of these people have come and gone, although Hugh Harper and Julie Gavorkian and Sarah Mayer still work on this project part-time. And also we get a lot of help from Pauline Weatherall at the BODC. So what did we do? We we basically construct a base map for the GEBCO bathymetry, and it consists of the land data, predicted depth, as I just mentioned, that's predicted from gravity, and then whatever ship soundings we can get together. One unique thing we do besides the predicted depth is we maintain an archive of clean single beam data. We just gather up the single beam data and compare it with all the other types of data and clean it. And actually that's been going on for about 20 years. And we don't want to lose this. We just sent this to Jennifer at NCEI. So in case I get hit by a bus, it won't disappear. One of the other things we do that has been very helpful for us is to maintain a source identification grid so that we can locate the original data that may need editing, go all the way back, drill all the way back down to the original data file. Something new for GEBCO 2023, adding more data, better satellite gravity, almost 300 cruises from BODC, single beam. And then our funding mainly comes from Office of Naval Research and NGS. Another thing we do is assist in the editing of the final GEBCO grid in collaboration with Pauline Weatherall, and an easy way to do that is to compare the base grid and the final grid, and we can find these outliers, and there's problems in both data sets. So we work to try to reduce those problems. Okay, well, thanks again for having me. I'm going to learn a lot.
Thank you, David. Next, we have Joshua Sixsmith. Josh, if you would like to share your screen.
So a little bit about myself, definitely not from a marine background at all. I've worked at Geoscience Australia for 11.5 years, and about 2 years ago, I took a change and went to the LDEO team, where I've been introduced to the marine world of data and processing. But my background itself is in electro-optical, terrestrial-based remote sensing, and through a list did a lot of mathematics, statistics, and spatial analysis itself. But at Geoscience Australia, essentially, there was a bigger need for people to do software development. So I had branched into this previously out of necessity because there's just too much data to try and do it manually. But with the analytics, the algorithmic understanding, I found a bit of a niche in settling around a lot of algorithmic development and translation of papers into code. And more broadly, data engineering pipelines and processing. So here I used to lead the development team of developers for the production of Geoscience Australia's analysis ready data. For us, this was surface reflectance, and broadly say not all surface reflectance is the same. People do different corrections, but it's quite an intensive process. But in coming across the LDEO team, I could understand the similarities in the processing that we do. What I was doing was looking at data that's transferring through or transmitting through an atmospheric medium. Now it's sound propagation through a water medium instead, but the collection methods are very, very similar, and the processing itself in the behavior mechanics of the correction is again quite similar. So it wasn't such a big transformation for myself as it turned out. But I work for LCBID, who we are. We're a collaborative initiative, and we comprise of many different organizations from state, federal government, and academia, as well as industry partners. So it's a collaborative effort from an Australian focus to pull data together, get organizations working together, commit to some standards so we can more freely make data available to people. And we are governed by a steering committee, again, from members from different levels of government, industry and academia, but really the community itself. So we don't necessarily drive it. We're driven by a team of people, and do what's best fit for the community. But on a bit of the topic of data processing and stewardship, transformations, how is it really important to GA? Well, we want to be a trustworthy source of getting information. And if data itself is not trustworthy, we risk the reputation of the people who have gathered it, but LCBID, Geoscience Australia, and in general, government, who we represent. But the data needs to be useful. So if it's not useful at all, why produce it? But there's also an important note is that the data needs to be fit for purpose. So I can't be expected to be using a piece of data in a way that it shouldn't be, like mapping versus, I guess, modeling. But if the data is not easily accessible, we go nowhere fast. People can't use the data. For years, I'd say a lot of people struggle to find data that hasn't really been accessible. But a big thing that's important to the government itself is this data that we process needs to be traceable. So we need to be able to trace back for a given data set where it's come from, where it's collected, how is it processed, what versions of software processed it. And through this, we are trying to build consistency. So not just in consistency in the generation of the data, but also in the consistency of what it's meant to be. That you can't just say, all right, we're going to use algorithm A for this data set. Oh, now it's algorithm B of this data set. Because repeatability in itself is quite an important metric. So if I guess this is probably the whole question of art versus science. If something isn't a repeatable process, it's quite difficult to start calling it a science. But efficiency itself in the processing, if it's not efficient, it starts to become a burden. So these days, humans are getting more expensive. There's more and more data, so costs are coming through. So what other metrics or what other practices can we do to reduce costage and expenditures? Thank you.
Awesome. Thank you, Josh. Christian Ferreira is next. Christian, would you like to share your screen?
Yeah.
Thank you.
So thank you for the invitation. My name is Christian Ferreira. I'm playing with computers since I was 10 years old. I studied oceanography, started working with hydroacoustics in 2000, sailing across Brazil. I'm originally from Brazil. Then I moved to Germany in 2007, started working with multi-beam data for the first time and with MB system at GMR, and then joined MARUM in 2009. Then at MARUM, which is my main institute that I have been working for a while now, well, it's an institute that is relatively new, that was formed in 2001. There are several research areas mainly focused on climate change, ocean interface, and sediment dynamics. We have around 10 to 15 cruises per year. We have a large marine technology group with ROVs, AUVs, ocean drilling equipment, and etc. MARUM is also one of the core repositories for the IODP program, and also we have our own core repository. We also host, together with Avi, a large data center or data archive called Pangea. And in 2009, we started the mapping group, which I'm part of. So why MB system? Well, MB system is kind of important in this story from Mahu and my story, because after several years of trial, we decided to stay with MB system. We have more than 100 cruises and many AUV dives processed with MB system, which for the AUV is quite important, MB system, because it has particularly some important tools. One of the other things that MB system is quite important for us is that allow us to create large data collections, and we can basically connect dozens of cruises and create maps that are of size of continents. Another thing that allow us to do with MB system is to customize the software for our needs. I started developing certain tools and helping with the code. And then after a couple of years, I went from an MB system newbie to developer, due to my background that dates decades with computers. And we have now an interesting project that is bringing Cube, or CHRT, the second version of Cube, to MB system, which will allow us to perhaps clean data much faster than before. And other things that we probably will discuss during this panel. Okay, thank you.
Thank you, Christian. And finally, we have John Morton. John, the screen's all yours.
All right, give me 1 second here. Oh, where am I? There we are. Share that. Are we seeing that?
Yep, you're good.
Great. All right, so hi, I'm John Morton. I'm an applications developer for the Global Multi-Resolution Topography Synthesis. And I'll just give you a quick rundown of our group and what it kind of does. So GMRT, it enables rapid broad access to some, it has services and interfaces for rapid access to integrated elevation data products in a variety of formats. We have services for providing gridded data, images, profiles, elevation at point, and we provide OGC compliant web services that can be used as a base layer for web map interfaces. It's used on a number of sites. And we provide those in multiple projections, Mercator, North and South Polar stratigraphic. We support data reuse and attribution through curated metadata describing the data sources, and web services that provide the data sources for any given area of interest, along with direct access to the processed swath data used to produce those, the grids. We improve the quality of publicly available processed multi-beam data through fit-for-purpose standards rooted in data synthesis and integration. So we're kind of a standardized workflow for working with this. And I'll talk a little bit more about that later in the slides, and about the tools and workflows that we use to support coordinated distributed data processing and avoid redundancy of effort. So the GMRT synthesis, it's maintained as a set of raster tiles at their sort of native resolution. So we have the GEBCO grid at its resolution, large set of contributed grids provided by researchers and research groups at various resolutions. Land elevation data from the NASA's ASTER Global Digital Elevation Model at 30-meter resolution, and also the USGS National Elevation Data Set for the United States at 10-meter resolution. In addition to that, we also provide our curated multi-beam synthesis, All of that is manually curated, edited by our group. It is nearly 1,400 cruises from over 500 chief scientists, a number of different operators, and it represents just the curated multi-beam synthesis itself represents about 10.5% of the global oceans. Our compilation is available in a variety of different formats, GDAL compliant raster formats, with or without GEBCO as the base layer. So ability to turn that off and see just the high resolution data that we have. And if I didn't mention it, the high resolution, all of our curated multi-beam synthesis is gridded at about 100 meter resolution. So those grids are generated on the fly from our source data, which is stored on a server at its native resolution and then brought together. We also have an image service that delivers images of this data and elevation at point. So just being able to find the elevation at a specific point, and then great circle arc profiles that can be drawn to just develop and show profiles across an area, or across a specific line, I should say. We also have web services. I had mentioned the OGC web map services, and also web services for all of these. We have web interfaces for our regular users, and then for our power users, we have documented web services that they can use. And all of this is also available through GeoMap app, which is a tool that a related group of ours maintains. It allows people to sort of introspect this data. And we provide access to comprehensive metadata, including full attribution to the contributors, summary statistics about things, and then processed swath files, the actual processed swath files that we use to create our grids. Let's see. And now I'll talk a bit about our distributable workflows and our distributable tools. So we have our GMRT tiler, which is a tool for creating these gridded formats that we need. But our goals here are to enact standards that are practical and yield fit for purpose products that can be used and reused, and improve the quality of publicly available processed swath files, and minimize the need for additional processing or reprocessing, and make sure that the data that is being collected is of high quality, and accelerating the pace of data integration. So we are distributing basically the tools we use for creating our gridded data products to other users so that they can verify the quality of data, view that data within the broader context of other data that have already been collected, and then ensure that it's readily usable, and minimize redundancy of effort, ensure that data quality is up to par so that data doesn't have to be recollected or reprocessed. All of that code and the instructions for its use are available on GitHub, and they've successfully been deployed on multiple platforms, physical and virtual machines on premises here, and at AWS, on people's personal computers, and on computers at sea. So, all right, I think that's it for me. Thank you.
Excellent. Thank you all. I'm going to steal back the screen share from you, John.
Yes, please do.
Let's see. There we go. Thank you. Okay. So it looks like we can jump right into the panel discussions. So all panelists, feel free to turn your cameras on as we engage in our discussion. I'll remind the audience that you will see questions pop up as we're speaking, like you saw previously. Looks like this. When you see one of these, feel free to interact and answer it. We may be talking, but you're welcome to go ahead and jump in, answer it, because it's only available as long as it's on the screen. So please jump in. So let's begin with our first question to the panelists. Who is your user community and how do they define your product? Example, interfaces, usability, accessibility, etc. And anyone's welcome to jump in at any time to start the discussion.
Probably start. Community for CEBIT is varied, so it's researchers, government, academia, and I guess the products that we are providing to people are predominantly the gridded product, and most of this is served through web service interfaces, and we primarily rely on people downloading that data. We are moving to the cloud itself, so having accessibility direct to the actual data objects located in the cloud is our next phase of development. And currently, formats that we're looking at, or we do use at the moment, are typical GeoTIFF, but we're looking at a data modernization exercise, a strategy, and we're looking at another format called TileDB. For us, it's a bit of a big change that we can handle both our point cloud information as well as our gridded information. But some additional benefits is it's not only cloud native, so it supports all object stores as well as all file format. File disk files. But the benefit that we do see is it has some inbuilt data versioning. So if I take a two-dimensional array, for instance, with a URI, say it's a file name on disk or an S3 object. If you want to manage this, and you want to output another version of it, old practices, other practices, you might remove that file and replace it with a new one. But if you want to keep both, and you start to introduce version names within a file, within the name itself. But here we can keep the exact same URI. So whether it's a continental product, a global product, we can have the exact same URI on a cloud object store or on your file disk. But we can store different timestamps, different time shots, however you want to call it. But we can access different versions of a two-dimensional array at the same point in time. So we can have 10 different versions of, say, a global GEBCO output product, and seamlessly access all 10 versions from the exact same URI without having to change links. This is where we're starting to look at, but we can apply that same kind of generality to not just gridded products, but also our point clouds.
I mean, I guess I could speak now. I would say that our user community is quite varied as well, but we do sort of provide a lot of services to the science community, both ways for people who just need a quick figure for their a paper, or people who just need some data from a region, to people who want to have who are power users, who are using our web services to pull a lot of different data, and to people who just want to create a web map with our data as a base map. So while our data is global in extent, and we provide services like our OGC web map service, it's focused on delivering sort of the best integrated resolution data for specific regions. We don't have a single grid that people can just download for the entire Earth with our data. We're allowing people to get at specific areas at the highest resolution possible for those areas. So,
Hi, this is Dave Sandwell. I guess I could. Oh, go ahead, John.
No, I'm sorry. I just wanted to make sure I didn't miss anything with that. We're still on that question, so you're good. You can.
Yeah, I think the users of our data are sort of different from the GEBCO group. we make this predicted global depths, and there's a lot of people that are interested in what's in the gaps for things like ship planning and creating regional maps for their proposals and that kind of thing. But one of the more important things recently has been is the physical oceanography community wants global grids that have the right seafloor roughness. And so we're creating synthetic bathymetry maps with John Goff. They aren't real bathymetry, but they have the right roughness to put into physical oceanographic models. And I guess the other thing is, again, we're on the edge of this whole process. We create global gravity grids. That's really what we do using satellite altimetry. And then we want to have matching global bathymetry grids for people to do gravity topography analyses and that kind of thing. And I think the GEBCO grid has sort of replaced what we used to do in the past, which I think is great. So yeah, that's.
Well, in my case, I think the main users of our products are scientists. But if I talked about the software side with MB system, I would say vast majority are scientists, but I've heard people from governments and from hydrographic offices and companies that use MB system for data processing and creation of products. So yeah, but on the institute side, we provide a lot of grids and process data, yeah, and other stuff.
I have a comment up here I see on the screen. Like it was, we did a survey for a project we did last year, and the predominant format that people were after was a CSV, an ASCII. That blew my mind because I haven't touched an ASCII in over 15 years. And I think I was reminded of it that you've got to give what the people want. But I also thought, well, we should also be trying to promote some modernization, maybe inform the community, because a point I mentioned in my slides before is efficiency. And ASCII isn't efficient. It's a poor medium for storing data. It's a lossy translation from a binary to some textual format. And coming into the old seabed field, people talking about the big data and look at the data, and the first things I come across is GSF file. No idea what it is, never seen one before. But I look in deep into it, and it's a raw binary format, and it's also we had them as uncompressed. And when I look at all this ASCII data, yeah, you can zip it up, but largely it's uncompressed. People use it in uncompressed form, and when people talking big data and it's uncompressed, and you got 100 terabytes of this, but as soon as you compress it, it might be 100 gig. Your big data problem is less of a big storage problem, or of an analytical problem. So in order for us to have some efficiency gains, rather than trying to deliver ASCII out to people, it's costly for us, and it's costly for the user in terms of download, and it's cost to store it. So we are sort of promoting more modern architecture to reduce that delivery of data. So if we're doing metrics on hey, we've downloaded a terabyte of data, that's great, but you can start to inflate it with there was one server that was just a terabyte of CSV.
Yeah, Josh, we also struggle with receiving ASCII data for our seabed 2030 products, and far prefer GSF, which actually an audience question that has popped up is I see the presenters have a focus on MB system, but from an industry, we see more of a trend towards Chimera Keras HYPACK. And how would you estimate the usage of MB systems versus these options? I don't know if anyone wants to jump into there. John, yeah?
Well, yeah, sure. I mean, we don't actually specify what tools specifically can be used for processing of these files themselves. So you can use QPS or Chimera or any other tools for processing that can produce GSF files. And we do use MB system within our processing workflow, but MB system handles GSF files just fine. So really, we're not Yeah, and GSF, by the way, generic sonar format. But we're not specifying a specific workflow for the processing itself, mainly for the integration into our final product and for sort of verifying the data and seeing it within its context. But yeah.
Yeah, this is Dave Sandwell. Yeah, we use MB System also because it's open and easily accessible, and it's part of our Unix type of platform. And we also use a lot of GMT. And I find that those two tools are very powerful. They have a steep learning curve, but they're very powerful, and you can walk away from your computer and have it process thousands of files. You don't have to point and click. So it has that kind of an advantage, but for a novice user, it might be more challenging.
I can say from the MB system perspective that I'm part of the group that is developing it, that we are currently working on a new graphical interface to make it more friendly using Qt, which is the same framework that you have in other tools like Fledermaus, and I think Chimera is also using that as well. So yeah, I understand that some people prefer to use other tools, primarily because MB System is not available on Windows, and the vast majority of the community sometimes use Windows. So I'm fine with whatever people wants to use. I have made my choice based on lots of trials, and yeah, I'm happy with that.
I'm
have a small comment there as well.
Yeah, go for it.
I don't have a background in processing of this data itself with this software. I've heard of these software packages. Our users or some of our producers within the CB team use Keras. They have been testing around with MB System, thing called Cluster, and Chimera, just to do an evaluation. But yeah, I guess my side of things have sort of come a bit further down the line. So I look at open source tools. So yeah, my first, when I was, hey, what do I do with this GSF thing? I went to MB System. Then I went to something else because I guess the output form from MB System was missing a lot of the data that I really needed. But yeah, so I guess for me, tools itself was largely Python on that front.
Yeah. So yeah, for us in our group, we use MB System because it's uniquely useful for legacy data. And I've used Chimera, and I like it very much, and it's very helpful in GSF. But this conversation kind of helps lead into the next question that we've already kind of answered a little bit. Or the last question within the user community section is what kind of integrated products do you deliver to your user community, format and resolution? We've kind of already touched on this a little bit. But if any of you have any additional comments to say on that, and I'll remind the audience that if they need to add any additional comments or questions, that they can select the Ask a Question button at the bottom of the page, and we will see it just like we did previously down here. So audience, feel free to participate in that regard. But from the panelists, does anyone have anything additional to add to this particular question?
Probably got a small comment. That was actually part of a project I did with John and Vicky last year. So on the question of resolution, that actually came up was that there wasn't a resolution that suited everyone's purposes. So we looked at the idea. Well, initially I looked at the idea and sort of pushed that was, can we grid directly from a point cloud? So we could provide a user with a sense of control as to exactly what they wanted. So sort of pick your output format, pick your projection, pick your vertical datum, and pick your resolution, and pick what area you're after, and gather the points together and then push it off to a gridding computation function. So it was what we explored as a possibility. And I think for me, it was quite a neat neat look at it, because I guess that resolution idea is it's fixed. If you want something higher res, I wouldn't resample, but you go and create it again.
And I think I probably in my response earlier, I talked people's ears off about the different tools that we provide for providing integrated products to our community. And yeah, like Josh said, we'd worked with him just last year and kind of prototyped some tools for also, and potentially this will be moving into the future, creating customized grids where users can specify which specific cruises or which specific contributed grids they want to integrate on the fly, so that they can create tool maps for their specific needs instead of what we think is best, I guess. So, but yeah, again, we try to serve a diverse audience and provide a number of services and respond to the community's needs and requests for those.
Cool. Christian, David, do you have anything to say on that, or you feel like you touched on what you want in that particular question?
Yeah, I think I touched on it. Yeah, fine.
Well, I would like to add about the format is that one of the formats that we share a lot of data is NetCDF, which is basically coming from MB System and GMT. But to my surprise, one of the biggest struggles that we have is that when we share data in NetCDF that has this grid compression mechanism that was, I think, implemented back in 2008 or 6. So it's basically more than 15 years old. And when we export data in this compressed format, which is the standard for MB System and GMT, there are still users reporting with up-to-date software that they cannot read our grids, which is still unreal. So I would ask, please, the users of bathymetric data to please ask your software of choice to update the NetCDF grid IO or drivers in case you experience that struggle. Okay.
David, you're set, right? You're good? Or
I'm fine. I mean, when I talked about the single beam data that we have, it's so small, we just have it in an ASCII format, and we have one file for every cruise, and we've been sharing this data with NGA and other places in an ASCII web, which is not the best, but it's portable.
Yeah, absolutely. So that concludes the user community section of our session. Next, we'll go into tools and environments for processing. The first question for our panelists are, what tools and environments do you use, and how do you process, transfer, and integrate that data?
Yeah, I think we sort of, I answered this before, but we use MB System and GMT and Unix, and we have some custom C code that we use for doing our editing, which is actually the biggest challenge we have is editing data. Maybe we'll talk about that later, but finding the data point that's creating the bad look in your map, and then finding that data point and then flagging it. And so a lot of those tools are actually custom in our lab, but we use Google Earth a lot. It's a really powerful tool. If you make tiled imagery from your previous grid, you can then go in and draw polygons at very high resolution and drill back down to the data point. So that's sort of how we do it. We're away from the Windows environment, which is unusual.
Yeah, I think I mentioned a little bit, but we do have a lot of our work is done on-prem on Linux servers at Lamont. We also, as I stated, we have distributable tools and workflows now. So we're starting to distribute some of that work to, researchers on ships and other things so that we can integrate, have them do some of the processing for us or be able to integrate their data more seamlessly into our workflows without needing to look at it too much ourselves. We rely heavily on MB system in general for our workflow, and also on our GMRT tiler is actually Java. So all of that's written in Java and distributed as a jar file. And that has a custom tool for the actual gridding of the multi-beam data. But again, it uses MB system for actually doing some of that basic manipulation and reading the files themselves. And yeah, we use commercial software as well, depending on what we need to do. So I know we have a whole group of people who work with processing this data, and a lot of eyes see each one of these cruises before they go into our final data product. So I feel like there's a very big human component for us as well in this.
From my side, I think I'll say the data processes itself, using Windows within a cloud environment, and Keras. Personally, for me, in this process and transfer, it's all entirely cloud. In Linux environments, Python is predominantly the language of choice for, I guess, services and interoperation. And the project I did with John and Vicky was, for me on this side of the process, it was actually all with TLDB Cloud itself as a software as a service. So cloud is great, but it's also can be quite difficult. It's quite a steep learning curve. So say, hey, I've got a cool function, you can use it. Okay? It's on GitHub, but now it's left to your own devices to set up, install it, whatever dependencies. But if you want this in a cloud environment, it's a difficult again, much easier on a personal computer. But cloud is where you get this scalable compute, but now you suffer the steep learning curve of spinning up a machine and tearing it down and having it safety and logging and all of this. So that safety, security, because you don't want something to get onto this machine and have a Bitcoin miner going. But what I could look at, and never quite got to that stage in this project with John. But looking through, he mentioned his Java code base for taking this GSF swath files to process through. What we could identify is that with minimal effort, with the point clouds that we were producing, more or less replicating this GSF swath, was that we could feed directly, or stream directly, instead of having to download that data in a physical form, we could actually stream directly through to the algorithm from an S3 object, and have something spat out at the other end. So this is an idea that we're looking at within Geoscience Australia more in object stores and streaming data to people's applications, as opposed to downloading all the time, because you start to have a disconnect. If someone downloads a file, data management comes into question, because what if we've updated it? You have to download it again and download it again, download it again. Whereas if you've got the most up-to-date data, we can directly stream through services. That was a good palette here that we could see in with TileDB. But with TileDB Cloud, it's like the difficulty of spinning something up in the cloud. Yep, well, we can negate that. And for our AusSeabed community, the idea is we want you to do these processes, certain applications and certain functions, but we don't need you to actually hire people to stand all these services up. We could share it directly with you, and you could just execute it. That any member of the community could execute it if it's public. Which I want to run this function 100 times, and 100 machines just get spun up for you automatically and torn down when they're finished with barely lifting a finger. Press enter on the key.
Well, regarding data processing here at MARUM, we use primarily, as I said before, MB system, but we also use everything we have available. So yeah, we use other types of software like Chimera, or we use carriers as well to read formats that MB system cannot read, so that we make sure that everything is accessible. But in several cases, we just use those tools to convert the data to GSF and then continue working on MB system. We are developing, let's say, a workflow where we put hundreds of cruises into a server, and we can query the data by indexing the data using the data lists, cascading to different other data lists, so that we can grid all the data we have seamlessly without any problem and without any need for a graphical interface. So we just fire a command and then create the grid, and that's quite robust, I would say, much more than any GUI tool that I know. And also recently we started developing a possibility to work with MB system in Jupyter notebooks. So the idea behind is that we would put a server with the data at the server, and then the user would connect to Jupyter notebooks and open a notebook that has MB system available in the environment, and then the user could basically do processing remotely. And the other thing that a colleague of mine was investigating and was successful is that to export the graphical tools from MB system through like streaming, so that we could use the whole workflow with MB system in the cloud without installing anything in the user computer. So yeah.
Terrific. Josh, did you have something to add?
Just I think
Yeah.
a good bit of it I really see in the cloud itself is that you can start to look at this thing that we call a cloud as a global file system. So it opens up the doorways for better interoperability and sharing of data, as opposed to trying to mounted my file server and attached it to, here's an internet access with some web services on top of it. And it really then depends on my internet speed connection as to how performant that thing is. But cloud really starts to change the game, and you can really treat it like it's a global file system. And if public and open data, I'm a big fan of that. That if I can access it from anywhere in the world without having to physically download a file, could if I need to work offline, but just to go to a different country and still do the same thing is quite powerful.
Absolutely. David, I don't want to leave you out. If you're ready to move on, we can move on, but
yeah, we can move on. Sure.
okay, sweet. So the next question is, are there technical challenges with respect to software and formats? We kind of spoke on this a little bit already with GSF and ASCII. I know that we've received several ASCII data sets that are a conflation of several different types of data. Like we had one data set that was a conflation of seismic and single beam and multi-beam. And we have to treat all of those differently usually. So we did have a struggle with that. We usually prefer GSF. That way we can extract out the ESFs and apply them in MB system. Of course, my dream is to be able to re-inject the ESFs back into the GSFs. But I'm not a programmer, so I'm not sure how to do that. But just to define those, GSF we already said was generic sonar format, and ESF is edit save file, I believe. Please correct me if I'm wrong. Yeah, so we that's the struggle that we have generally, is that we really prefer that swath sonar format so that we can pass on the edits. But what about the panelists? Whoever
Yeah.
can start.
Yeah, this is David. I could say a few things about data formats. I think we deal with more of what I call homeless data. These are data files that come in from who knows where, in what format. It could be MATLAB, it could be any weird format. People just send it to you. There's very little metadata. You can try to find it, but it's very heterogeneous. And so each data file or each format is a new struggle. We just dealt with a BODC single beam data. It was a different kind of format. So there's no easy answer to this question if you're going to try to integrate lots of different kinds of data. You just have to, I tell my students, you got to crack the data format, and that sometimes takes longer than processing the data. So that's my take on this.
Yeah, again, that's one of the reasons that we push so strongly for standardization and workflows and making sure that people actually document what's happening at each stage and what sort of processing happens and who's responsible for it, who can you contact about what's going on with the data. There's so much provenance that needs to travel with the data to make it useful. And so maintaining that provenance is vitally important for this kind of data. I was going to mention, as far as software issues, like MB system is a very important tool within, it sounds like, several of our workflows. And I think there's really good tools for, like, right now it has like a homebrew install that works great on Mac, but I'd love to see something like that if it was like in Yum Package Manager or apt-get, so that we could actually install it on Linux servers and keep it, up to date without having to do a from source install each time for new versions. It'd be good to have. It'd be good for, I think, workflows in general to be able to have that be something people could install pretty easily and make it a little bit more distributable if there were better ways to get those, or like precompiled packages or anything for MB system that would make it easier to drop on Linux servers or on, whatever box needs it. So.
I guess my take, I'd never come across a GSF. Just heard the word edit save file, never heard of that either. So for me, again, I'm learning quite a lot. It's a new field for me, but coming into this project, and I'm given this GSF data, and it was quite difficult for me to try and actually do anything with from a developer point of view. MB system got me so far, but didn't have enough for what I actually needed to extract from this data, metadata included. So I agree with John and David, this provenance is absolutely vital for us in providing more information to the user. But as far as ease of use, I didn't find it very easy to use. Well, there were a few tools, but where we looked at from the community was, there's a sea of formats, and there's legacy files, some end of date that things don't read. Maybe MB system is probably the only thing that reads them, and MB system is quite a heavy piece of software itself. Looking through it, it's a beast to maintain, but so I don't envy Christian, but it's kind of where we looked at was an open format was highly important to the team and Geoscience Australia in general. So we looked at TileDB for this, but why we settled on it was that it was an n-dimensional abstraction, so we can store any kind of data you want. So including like single beam, multi-beam, grids. We could throw anything at it, and we could model the data in very different ways. But that'll only get you so far. You can use the TileDB API, and we had users from various different languages. So here they provided an API where you could use R or Go or C, C++, Python, and all access the exact same array. So researchers from various communities could all point to the same array and read it directly. But I guess even more important, I think this is why APIs are a brilliant idea, is that they're there to try and abstract away so you don't really care about what a format is. So it's why MB system does well. It abstracts away, doesn't care what the format is, because someone has done that hard work to interpret what it is. So for us with TileDB, our users predominantly using GDAL with open source tooling, GDAL and PDAL, and TileDB folks wrote those APIs. So you could still use these other software tools to get access to the array without having to use the TileDB API. So it's all well and good to come up with a new format, but if no one can still read it, or they have to make use of an API, like a raw API to access it, makes it harder. But if there's already available APIs within packages, whether it's MB system or PDAL and GDAL, it reduces that barrier of entry.
My take on the data formats is that we decided to go with MB system a while ago, primarily because the data that you process with MB system is basically the raw data augmented with some other datagrams. So one of the idea that I was a big fan of is that you can basically reverse your process data down to the raw data by using some commands that strip down all the augmentation you did on the file. So that for me was a big deciding factor for MB system a while ago. Also because when we played with several other proprietary software, we found problems with the GSF export, where the data was somehow translated wrongly in GSF. And the other issue we had, for example, was a software was able to export GSF but not read it back, which was bizarre, to say the least. And yeah, and I think and one of the things that we try to avoid is to convert data to GSF, because that's my personal take, I guess, is that I don't like the generalization that happens in GSF. I like to stick with as close as I can to the raw format, and that's my personal take on that.
Awesome. We have a question from the audience. Let's see, where did it go? There we are. If you can see it on the screen, we, Kongsberg, are trending towards Docker's and Kubernetes cluster. How about distributing your processing steps that way? Any experience with this approach? I don't know if any of you.
I know we've done some talking about containerizing some of our tools. So actually, creating a little container that has all of these things within it. We do currently have, as part of the Geo Australia work, and we could certainly refine this as well, but we do have an AMI snapshot that we could distribute for people so that they can spin up, say, EC2 instances or something similar to that, allowing them to do this sort of processing on the cloud without too much customization or anything like that, but just have something ready to go. But yeah, it's definitely in our heads. It's just there's only so many hours in the day.
From the satellite imagery processing, yes, this was used quite a lot. But it's also not for the faint of heart. Kubernetes is quite complex, very complex. So there's a team of developers maintaining and this, and so it's not cheap. And within Seabed, we're quite a small team, so building and maintaining this kind of stack is not necessarily viable. Hence, we were looking at software as a service where someone else has done that hard work for us. And this for us was TileDB Cloud, so we could start to just concentrate more on the actual algorithmic tooling that we needed to do, and push that to the cloud and just have it auto deployable for us via TileDB cloud and then shareable and scalable. So the cost of setting up and maintaining and running Kubernetes was simply not something that we could sustain. And even other areas within GA, it is quite taxing on those areas that do that, because like staff turnover, new people come in, need to relearn the stack. So it's not just maintaining the code base, it's maintaining the people to keep this in, especially cloud engineers. They're in high demand. Most get snapped up by Amazon, Google, and if you do get some, it's quite pricey. So software as a service was quite much more attractive for in ramping up, moving forward pretty quickly, but then sharing with our community.
Awesome. Unless we have more to add on that, we could move on to our next question. Let's see if I can get this to work. There we go. What kinds of data are you integrating into products, and how are you doing that? We kind of already touched on a little bit about like all the different types of data. So more so, like, do you use the same workflow for all data types, or do you use different workflows for different data types? I mentioned that we have a different workflow for when we received swath format data versus then when we receive raster. We use, of course, raster. We use the BIS, or the bathymetry information systems, which is within ArcMap and now ArcPro. It helps us layer all of our rasters in such a way that we're able to prioritize those of higher data quality, whereas our swath data format goes through a GMRT workflow, which John could talk a lot more probably about than I could. But yeah, so what workflows do you use to approach the different data types?
I guess I could answer questions very quickly. Again, we use a lot with GMT, and our workflow is basically to dump whatever raw data we have into some kind of binary file and then feed that into block median and GMT, which is a wonderful program. It can take the whole globe on one, a very high resolution. And then Surface is another GMT program. So those tools are sort of our bread and butter, and they seem to work. You have more data, you just need a bigger computer.
And I think I did talk some about our workflow for integrating our multi-beam data, but we do also have, I don't think I mentioned that we also have like assessments of the quality of the data itself and how much we want certain cruises to sort of affect elevation when things are overlapping. So we do a little bit of extra processing there, but we have our own in-house gridding algorithm where we pull the actual pings out of the file using MB system, and then a tool that I think both Josh and I kind of dug into this one and tried to figure out what was going on with the gridding tool, but it's a lot in there. And then, yeah, we also have ways to integrate our contributed grid data that is just the XYZ values, and ways to modify that in the sense of, like, if we want to just have values above or below a certain depth show up, or if we want our multi-beam data to shine above that, or we think that this grid is like the definitive source for an area, we can specify that as well. And yeah, and we do a lot of and all of that gets kind of put together on the fly when users request data from a region. So
yeah, right. It's all sorts of data as well. And again, depends on whether we come in as raw or level 2 or level 3 as to what we do with it. If we get given a grid, we will push that grid out as is. But if we're given raw, then we process it. At level 2, if it's then we process to a grid. But in this project with John, we're given all this data, and I was told, here's all this level 2 data, and turns out even this level 2 data, if it's in this GSF, was not the same. They were processed differently, applied with different corrections, I guess. I don't quite know, but even the data contained within was different. So for me, I started to look at here in other decision-making processes to say, well, it's hard to really qualify this thing as identical when it's not. And can we categorize this into subcategories? Like, is it like an L2A, level 2A, level 2B? So we can start to give some qualifiers around it, so we can this is why metadata and provenance is quite important, so we can make decisions early on as to where within a workflow process this thing can go. Where is it suitable? Like, if it doesn't have certain attributes like uncertainty, well, we can't push it through a cube algorithm, or we need to produce that so we can then push it through the algorithm. But it gives us a bit more early on decisions on where in the chain it needs to go.
Well, I primarily at MARUM work with multi-beam data using MB system, so ship data and AUV data, quite a lot of AUV data in the last years. But more recently, the people working at Pangea, the data repository here in Germany, started requesting for support for other formats that are single beam related, like EK60, EK80, and I was talking with the people from the BSH, the German Hydrographic Office. They were also requesting, oh, could MB Systems support EA 400, EA 460, and some other single beam formats? And I was like, well, it's possible. Somebody has to work on that, and then we are discussing that. And also the people from the database from Pangea was also requesting, oh, could you guys support ASD format? And then for those who don't know, ASD is a format from Atlas Hydrographic. A company here is from Bremen, Germany, and they developed this format years ago. And the main reason that the Pangea guys were requesting that is because the German research fleet is mostly equipped with a sediment echo sounder called Parasound from Atlas, which now belongs to Teledyne. And this format is obviously containing a lot of navigation data that we cannot read in MB system. And then the guys from the database who use heavily MB system would like to access that. So that's another thing that we are assessing now, is to enlarge the possibilities. And I know that Dave Carrez has been working a lot with LiDAR data and sub-bottom profilers. So yeah, and also photomosaicing, because he's now doing some crazy stuff with LiDAR data and photomosaicing and creating bathymetric maps with a scale of resolution of 1 or 2 millimeters. So it's pretty insane.
I'm wondering if there's a way to allow a little bit more of a distributable way for users to define how to handle input and output of data formats into something like NB system, if they could be able to write their own sort of modules or classes for that in-out sort of way, or if that's something that sort of the NB system developers themselves need a strong hand in to develop.
Well, somewhere somewhere deep in the MB system website, there is a guide that was written by Dave Carrez in 2014, I think, of how to write a new module for to read the new data format in MB system. So I have worked with that guides, and I say it works. But I started with a format that it was extremely large, and then I had to have the support from Dave to finish it, because it was the specification of the format was the S7K 3.0, and it was hundreds of pages specification of the format, so that was quite large. So I should have taken a smaller format to start with.
I know that like GDAL kind of at least documents that for their users too, and ways of how to write tools for reading in arbitrary raster formats or vector formats in the case of like OGR. So
yeah, we sort of have to prove that.
Yeah.
So one thing, I've been hearing a lot about Dave Caress, who's a really wonderful programmer, but we should all worry about what happens when he's going to retire and where that whole MB system development is going to go. And we should be prepared for this. This is happening. I work a lot in radar interferometry, and it's happening in that community. And NSF will actually fund people to pass on the development to younger programmers. So it's something we should worry about if we're really relying on MB system.
I don't think it's something to worry about because Dave still has 10 years ahead of him. But of course, something we have to start discussing now because, you know, and I have been having discussions here internally in Germany, and I can say that there is a strong interest into joining this development, but we first have to assess the community and who's using, and so to set the scope of the project. So, but there is, I would say, we could get a strong support here if we put it nicely, and the big higher ups agree to pay for that bill of a developer salary.
Yeah, we I know early on in the pandemic, Vicky helped lead a group along with John it was like going to be an MB system working group to address that exact problem that you mentioned, David, because we wanted to have you know, some sort of support system just in case, you know, Caress decided to retire early or you know, anything unforeseeable happened, because it is a concern that we do not have you know, a lead programmer in that regard for MB system. And we wanted to make it a sustainable model, MB system to make a sustainable model. But I did want to point out we have a comment in the chat from our Kongsberg colleague over here. So if you didn't, if the audience did not see it, or panelists, I've got it up on screen now. Okay. Hopefully we will start back up that MB system working group once things calm down a little bit. Okay, let's see. Our next question was, with the growing volumes of publicly accessible raw data, how do we coordinate and not have multiple people processing the same data? I know we struggle with redundant effort, and we want to try to minimize that. We have a lot of coordination efforts here at Lamont to do that, but I'm curious about like what other groups the efforts that they might have to help mitigate redundant effort.
I'll take a stab, but I guess probably, I know there's lots of groups around the world that process raw data, but for individuals to be processing raw data, what is the value add, or what is the necessity to say, hey, someone has produced a grid, I don't like it, so I'm going to go back and from raw. Is there a necessary impact of change? Like, how significantly different is your output to something else? Maybe some work in that field or this area might highlight the importance of doing a new method, or even highlight the importance of, hey, we all don't have to go process it again and again and again. I guess, what is the real output? What are people after? But I think from the satellite world, no one but the operators actually process raw. People used to, not anymore. It's not worth it. unless you're really at the sensor instrument side of things, and then you're working for the satellite company, you won't touch it. Most people want derived information because there's so much of it. It just, you'll be left behind if you want to try and do everything from raw.
I will mention that we have web services that state which of our, what we're currently working on, what we're currently processing, and what's going into GMRT and what has already gone into GMRT. But at the same time, we're trying to provide all of our, as I stated, we attempt to provide all of the attribution information, all the provenance for all of our swath data, and also all of the processed swath data that we produce so that other people can use it directly instead of having to go through their own workflow for this. But having that available and having all of that well curated and well documented. Again, provenance is key for all of this. Having all of the metadata is key. So.
Yeah, this is Dave Sandwell. I think having a clearinghouse for all the cleaned and corrected data would be really important. And NCEI has part of that, but they don't keep the most recently edited multi-beam data. I know they have different versions, but it would be good to keep that online at NCEI. They're the repository for all the data, and try to keep it up to date. I mean, I saw a question, maybe I'm jumping ahead, but one of the issues with the multi-beam data is when you have a single cruise, it can look just fine, but when you start integrating it with other data, it can look really bad. And so someone will have to go in and make that tweak to the sound velocity or something. And only one person, no one should ever do that again. It should only be done by one group. So I know Lamont's doing a lot of this, and it's a great service. Thank you.
Well, here at MARUM, what we are doing is that we will submit a lot of process data to Pagea, and then the group was kind of large here, but a lot of people left for several reasons, and currently the mapping group is just myself, but we are expanding the group a lot in the next year. So I will have a new colleague in just a month from now, and then we will start growing the group again. So yeah, we don't have so far I know everything that is processed here because I'm the only one now.
We have, I know one of the problems that we face is like how we decide which version of the data is best. So it's like sometimes we pull things from repositories, and we have to then go back to raw and apply the ESFs or the edit save files to those, and then we generate a new version of the processed files. And of course, we think our version is probably better, but how do we make that determination? It's many versions makes for a data management nightmare. So definitely a challenge that we face regularly.
Yeah, I definitely see the whole process is subjective as far as definition of quality. It's something I'm trying to unravel, even with in AusCBED, like to help determine metrics as to what we're stating as a quality. So even if we're doing some versioning of a process, like how different it is to a previous version, but is it significantly different? In a good way, a bad way? Is it within tolerance? If it's within tolerance, maybe we don't release it because it's not that significantly different. I can understand David's comment before, the look at one survey, looks all right, now start bringing it in with other data, and all of a sudden what was clean is now looking quite noisy. And I guess there's the benefit of experience that others had that I didn't have in understanding the data, but I can understand from a statistical modeling point of view that, and even I think it was, I'm trying to think back, university, Tobler's law of geography learning. Everything's related, but near things are more related than far things or distant things, or something like that. So from a statistical point of view, you will get natural clustering for things in a natural world that are similar. So as you start to pull more data in, you can start to identify noise and even automatically flag it. Whether or not you need to go and readjust it, I don't know. It's a question for someone else. But I look at it from any point of from a point of view that data is data, and removing data can be a no-no, or at least can we flag it that it has been removed in quotes, as opposed to physically removed, but we just attributed that it was identified as something not ideal. Because I think the purging of data, I think, yeah, lose it, it's gone for good. So you sort of hope you've got data management practices in check.
Yeah, I know we have that struggle ourselves with the data that we receive, because sometimes we will receive certain data sets that they're very noisy, and there's like, do we decide whether or not we want to add coverage and keep the noise, or if we want to remove it? Like you said, it's very hard to decide that, but that's why we prefer working with swath formats, so that we can go back to the swath format and fix these problems. I very specifically work a lot with like refraction issues, because refraction issues are very, very common, especially in the transit data. And so instead of removing the horrible, frown in the data, we try to address that as best as possible to get it to at least as true to what the seafloor should be, or what we assume it to be. So you want to, Josh?
Yeah, I think a final comment. It's probably then important, I would think, as well, to inform the people that have provided this data, hey, this is what we've had to do. It's like a feedback loop, I think, is vitally important to any producer. That, hey, even from a service, I'm providing a service, if it's not up to scratch, let me know so I can fix it. But if I don't know it's wrong or something's bad, I'm not going to fix it unless I become aware of it myself. So yeah, a full feedback loop in data processing for acquirers, everyone, even people who go do the survey. I think, hey, here's the information that we've seen, and we think you're traveling a bit too fast for trying to get some quality data. Maybe slow it down next time. I don't know.
Yeah.
I mean, what Hayley mentioned is exactly right, but it's all about money, really. When you do a transit cruise, should you slow down? Should you deploy the XPT to get the sound velocities? And NSF doesn't want to pay those extra dollars to get a high quality transit cruise. Yet sometimes those cruises go through places that have never been surveyed before. So they're like the most important cruise. So you guys are doing everything you can to rescue it. But
right.
Yeah,
yeah, we do all of that in our post-processing. And we have a lot of Mac tools that can be utilized for injecting these SVPs. But yeah, I mean, we're really grateful to have MB System to work with MB Velocity tools, so we can actually resolve these refraction issues.
Yeah. And sorry, I'll let you go.
I would like to add, I don't know if it's totally related or unrelated to this question, but one of the ideas behind here is that once the implementation of CHRT cube is done in MB System, at least the people from the database, they here at Pangea, they want to run cube or charts or on all cruises that they have, like hundreds of cruises, and at least generate like a basic grid for all the cruises, so that to not have just the track lines available, but to have, like, say, a basic grid that is filtered. So, and then people can decide if the grid is good enough. If not, they download the raw data and then they process themselves. But I think to help with that, And in the process data, there is a tool that a student of mine has developed, and we are currently alpha testing that. Is the tool that basically you give swath files and it goes to the Ocean Archive and downloads, I don't know, 20 gigabytes of temperature and salinity to calculate SVPs with multiple resolutions, and then you can select the best SVP for the tool, so that you basically give a list of files, and then the tool goes to this database of SVPs and collect the best SVP. So it's similar to how we have already in B-Velocity tool. It's just that the tool is doing that automatically, selecting the best SVP, and it's also comparing to the SVP that is in the data to see if that SVP is the best one or if there is a better SVP. So.
Yeah, and I think it sounds like we're all on the same page here in a lot of regards, but one of the big reasons we have these distributable tools that we have is so that like providing them for researchers at sea so that they can see their data within context and immediate, or not, close to immediately catch these issues. Hey, there's a frown in my or in this data. This is not good data. I need to fix this or do an XBT or do something to ensure that this is up to par and that this is data that's usable by the community once I'm off the ship. So again, the importance of making it distributable and communicating with people as quickly as possible. So
yeah, I got a small comment on the economics, I guess. I think David's comment on the economics that NSF, it's the funding, but at the end of the day, what are they funding? If the objective is to have good quality data out there, it might be worthwhile funding a survey to gather quality data, because at the end of the day, satellite-based remote sensing would never have worked if that kind of same mentality went into, hey, instead of $1 billion for a satellite, it's only going to be $1,000, and we can get some consistently poor quality data. Sure, and then the economics factor comes into people's time and effort to then build all of these other tools and reprocessing of data to make it look better, which itself has not just a cost impact, but an environmental impact in the compute services required to reprocess and continually reprocess the data, as opposed to, hey, could we acquire it, spend a little bit more and acquire it consistently.
Yeah, absolutely. And this kind of leads into our next section. It's I'm really cognizant of time. I lost track of it because we were having such good discussion. So I'm going to skip a few questions and go immediately into this next one, which is, in your experience, are there unique bottlenecks or challenges revealed during data integration? And what solutions have you developed to address these? Let's see. And I'm going to immediately prompt the previous audience participation question while we talk about that. So for us, like, for example, we have, have you seen in reviewing data through the lens of a single survey versus a compilation? Like John mentioned, we have underlying data that we can compare in GMRT, where we can compare things immediately to and be like, oh, I think there was an example where that Vicky and John both give about the fabric of the seafloor happened to be backwards, and we discovered a problem with some sort of MB system hiccup. Yeah, so any bottlenecks or challenges during data integration that you can speak on?
I think I stole my answer with my previous answer, so I won't bring people through that again. But that is, like you said, that's a big part of what we do.
Yeah, one bottleneck that we have is that if you're integrating data from many sources in some area, and you try to do that interactively in one of these tools like FleeterMouse or so on, there's just so much data it'll like crash the system. So yet a human can go in there and flag the bad data point. And so that whole integration thing is very clunky on our end. It's very clunky. We basically draw polygons and then we go back and regenerate the grid and so on. And it's this endless process. But the most important part of that process is being able to click on the map where the data is bad and figure out exactly which data point it is that you need to correct or flag. And that's a challenge. I know there are tools for that, but I don't think they're really up to speed for giant data sets.
Yeah, I think bottlenecks is a human factor for us at the moment. Like, there's not a lot of people. Humans are expensive, and yeah, I guess the continual iteration of like, let's try and improve this thing or flag a point. Where is it? Go find it. Cool. Edit. And it takes time, but the impact that can have on an output product as well is the repeatability factor. Can that human guarantee 100% of the time for 100 times that they're going to be able to repeat that process, even if it's a year later? It comes into question. So it slows down our process. So we have sort of starts and stops. Things are going well, and then it hits a human, then it goes back to a computer to process other pieces, and it's back to a human for review or approval. That these for us are big bottlenecks. And then if there's a full compilation, yeah, told this thing can take months and years. That I look at it, it's like, hey, can we reduce that cycle? And if we can, and we can do it repeatedly, and then testable, and verified, or independently tested, checked, is it worth investment there? And my thoughts are, yeah.
Well, about bottlenecks, what I have seen over the years is that one of the biggest bottlenecks when you're starting a group, like we did a few years ago, was having a multitude of formats and not having a single software that can read all of them. So that was that's why that has led us to start to standardize the fleet of vessels to have perhaps vendors that are more open to provide data in formats that are easily accessible and also well documented. So I will not say any names to not favor one vendor of the other. Okay, so but yeah, that was a big bottleneck. The input formats of raw data. So yeah, other bottlenecks is people, right? To process data, it takes time, and of course we can use filters. But one of when you work with geologists like I do, the biggest thing that we are aiming for is the detail, is to go very deep into the data. So we're not creating nautical shots, we're creating detailed maps of structures on the seafloor. Therefore, manual cleaning is sometimes, or most of the time, is required to achieve that level of detail. So, and then personnel is a big bottleneck. So yeah, that's my take.
Yeah, absolutely. I know that personnel was a big bottleneck for the sound velocity corrections that need to be made. We don't always have the time, or on the ships, we don't always have the time, just as David said. And I know for us, one of the bottlenecks for processing, I've skipped with to ahead on the audience participation. What bottlenecks do you experience? And personnel, of course, is number one, just like all of you have pretty much said already. One of our problems is that the IHO specifications, they don't necessarily work for deep water. So it's hard for us to find a set of standards that we can follow. So we develop our own, and everyone ends up developing their own. It becomes a cluster that everyone's following different set of standards, and none of us have like met in the middle or agreed upon what we want. I mean, there are sometimes like the GEBCO cookbook previously mentioned, or the MAC multi-beam advisory committee wiki that can help with those standards, but that we definitely struggle with finding standards specifically for deep water. And let's see, I think I wanted to keep this one up a little bit longer, but we'll just go ahead and skip ahead. I think we all came to a consensus that we need more people for the most part. People are expensive, hard to find.
Or we need the AI to do the
or we need a
for
proper
us.
AI. Yeah, absolutely. So I think this question, they kind of fold in together. So how do we make sure that our products are going to be useful in the long term, and how do we make them fit for purpose standards that will optimize efforts spent on data processing? We talked about redundant effort earlier, and I mentioned the IHO standards are inadequate for us for deep water, but what are your thoughts on these questions?
Probably quickly, it's a continual review. The process, what are people after, even it's year after year. I guess you all run the risk of like MB System, for instance, run the risk of what's the business continuity if the mate developer just, hey, I'm done, or whatever worst happens. But yeah, it's so I think in order to stay relevant, you got to keep moving ahead. You got to ensure you modernize. Otherwise you get left behind. But yeah, continual talking with the community and getting feedback.
Well, I will say in terms of keeping our data, sort of making sure it's useful in the long term, again, I keep harping on this, but provenance and ensuring that all of the metadata associated with it is there and all of the attribution is there, and being able to, zoom down to the actual swath file itself that was involved and produced and gridded as part of this set of data, knowing exactly where that data is and exactly where we can go to find it. That is so important for all of this. You can't lose that at any point. Again, it's why it's frustrating for us when we get a grid of data that doesn't have any of that. And again, we can't really fix it, but we also don't know even where that bad data came from or why it's there. So yeah, I mean, that provenance for any of this is so important.
Absolutely.
Yeah, I would say that I think of this in terms of the user community, and there's really three types of users. There's sort of the high school kid who wants some nice pictures of the seafloor for his report or her report. There's the scientific user, physical oceanographer, who wants a realistic bottom topography to put into their numerical model. And then there's the high level users like us that want to get back to the raw data and look at very detailed things. And so and I think that's that first community that's really the biggest community by far. And the second community is probably where we're gonna, when I write a proposal, that's what I target in the proposal, that the users are people slightly outside of your field, but they're scientists. So I don't know if that answers the question.
Oh yeah, that was great. Christian?
No, I just would like to say that my answer is very similar to John Morton, so I will not go to cover the same topics.
Awesome. That means we can move on to our last section within the last few minutes. So opportunities, what opportunities do you see for collaboration that can accelerate the creation of high quality, openly accessible data products?
Open data in the first instance, easily accessible, but open tooling, so we can start to use some similar tools that are easily accessible for working together. Here, I mean, I've pressed cloud quite a bit, but cloud can make this simpler, can also make it difficult, but for collaboration, it can definitely make it much more inviting.
One thing I would say that CVED 2030 has done a wonderful job at helping the collaboration efforts around the world. And I know they're pushing for open data when it's possible. But really the whole, it seems like a small amount of funding that has been put in to get a large payoff. So I think it's a great thing.
Yeah, I would just say more communication in general like this would be a good idea. Just being able to come together and brainstorm this or have regular yeah, and I know that we were mentioning that there is going to be that meetup at Lamont in May. So that's, again, that sort of thing is important to get people talking about this stuff and wondering about how we're going to move this community forward.
Yeah.
Establishing those standards and things like that would be great.
Absolutely.
Well,
Yeah.
one thing, what I would say is, like, as Josh was saying, open data, open software. But one thing I would like to add is that whenever I go to an area that I'm supposed to help people mapping, I go through several databases, like the NOAA database, like the IFREMER database, the German database, and try to download dozens of cruises and raw data. So one thing that I would dream is a website that basically compiles all these databases so that I can search at a single place and not have to go through all the largest databases to get a glimpse of all the data. So I would like to have a global database that maybe connects to the smaller databases.
I mean, we don't even necessarily need a global data. Yeah, I mean, we can create something that sort of is able to communicate with all of those on the fly and do that same sort of process that you would have to do manually, say independently, so that you can know, hey, somebody's got data here. That would be a tool with a lot of use for the community.
I just wanted to show that Aaron has put into the made a comment that we aim for much better than IHO in deep water. Our goal is to create a good seafloor model first and foremost. Sometimes that takes more than what standards deem permissible, and I would totally agree with that. That's what our that's our quality standards for GMRT as well, and when possible, also of course with our CVED 2030 products. Thank you, Aaron.
I think my only question back on that is, what's good?
Yeah, there are certain things that we can determine are not accurate depictions of the seafloor. Like when I was talking about the sound velocity, it's, you know, we know that the seafloor is not frowning there, so we can make that a little bit better, even if it's only 20 meters and 4,000 meters. You're like, well, it's only 20 meters, but I'm able to make that so much better with MB Velocity tool. It takes me like a minute maybe to resolve that. So there are certain things that are definitely easier to deem not permissible. You know, but yeah, it is good, can be relative for sure. I'm going to leave the next question just open to the audience for a moment. It's, what is the future of data processing, integration, and delivery do you envision? You're able to, if you would like to, click the ask a question down at the bottom and input your answers. Yep, you can see participants are typing now. That way we can gather your responses. I don't know if any of the panelists have any final thoughts on this question. We're a little bit over the hour. I apologize for keeping you guys. But if you have any additional thoughts or comments to make, love to hear them.
I think I'd like to see a lot more open algorithms. So I know a large part of, there's a sense of protectiveness around some algorithmic developments. My IP, I've spent hard time and effort, and you lock it away. It doesn't really benefit the community as much, even if you're selling it out to someone. So open data, but also open algorithms itself, open science.
Absolutely. Okay. Any final thoughts from John, Christian, or David? No, you're good. Okay.
Just
I was just
thanks
making
for
sure. I didn't want to
organizing
cut you
this.
off. I know like I said, we're over the hour. I apologize for that again. I wanted to say again, a huge thank you to you, my panelists, for such a fantastic discussion. And of course, the audience for your participation in the poll questions. The insight you provided today by your feedback is absolutely invaluable. And I look forward to seeing all of this data and information synthesized and presented in our May workshop. Also, thank you to Tina and Shayla for all their backstage work that they've done, especially in AHA Slides. It's totally new to us, and it's been fantastic. We loved using it and interacting with the audience. And of course, to Jen and Vicky for their guidance and incredible work on the webinar. Vicky, Jen, I assume you want to say a few words before we cut out here?
Very, very few words since we are a few over, and I think that you summarized perfectly. This was the ideal session to end this webinar series on. This was such a fantastic conversation and really good participation from the community, and we just really appreciate all of your time. Josh, we know what time it is in Australia. I'm sorry, and thank you for being here. All of us, even those tuning in, we're all very busy people, so it does not go unnoticed that you put 2 hours and 5 minutes aside to join us today. So thank you. I want to give the mic to Vicky to close us out and to just kind of remind us again of where we're hoping to go with the information we've gathered this week. So thank you.
Thanks, Jen. Again, echoing all the thanks. This has been great. We got into a lot of really good topics. So thank you all panelists. And thank you everyone who's participated this week. I think we had a great session of webinars. I hope that folks that were not able to join in live are able to tune in on YouTube and catch up on these exciting conversations. Just a reminder of next steps. We will be synthesizing the feedback that we've received so far and soliciting the community for more feedback that we will bring together to share with everyone, but also to help shape the workshop that we will be hosting here at Lamont. The dates that we've nominally set aside for that are May 23rd through 25th. We will be communicating more about that very soon, recognizing that travel and logistics planning needs to get underway. But again, we will be offering that as a hybrid event. So if people are unable to come in person, we still would like to make sure that you can participate virtually. And, again, we're really hoping that that session is going to help us move towards some of the answers. We've heard a lot this week about things that are going on, some of the challenges, some of the opportunities, and we really want to take that next engagement as an opportunity to start to pave the path forward. So again, thank you everyone for tuning in. Thank you for participating. We look forward to continuing the conversation virtually and then in person here at Lamont in May. So with that, I